Here we've got a beam that's roughly 2 meters long, and three forces are acting at the end of the beam at the 2 meter mark. The forces are 200, 200, and 260 newtons, F1, F2, and F3 respectively. And we're trying to find the torque exerted about this point labeled P, which again is 2 meters away from where these forces act. Now, the formula for torque is fairly simple. Torque is simply force times the distance to the pivot point. Now, the only thing you've got to remember with this formula is that the force and the distance have to be perpendicular. They have to be 90 degrees to each other. If the force and the distance are parallel, it doesn't generate any rotation, which is what torque is all about. So torques can either be clockwise or counterclockwise. So in other words, if I had a force straight in line like this at 200 meters, imagine I'm tugging straight along that line labeled U, so it's exactly in line with P, it's not going to cause the beam to want to rotate either clockwise or counterclockwise. It's just going to tug on it. So it's not going to generate any rotation. So there has to be a component of the force that's 90 degrees to the distance back to the pivot. So fairly straightforward to calculate. And you can see right away, if I look at force 3 here, it's 260 newtons, and it already is 90 degrees to the 2 meter mark. So we could easily start with the F3 and get a torque fairly simply. So let's start with that one. If I'm trying to calculate the torque due to F3, we'll label it torque 3. So I go F3 times distance. F3 is 260 newtons. That's the perpendicular force to the distance. And my distance is 2 meters. And when I work that out, I get 520 Newton meters. And if you look at it, if I'm pulling along this line, it's going to want to rotate like that, clockwise. And clockwise, we'll just label it as CW. All right, let's look at the torque generated by F2. Now, F2 is at a bit of an angle, so it has a component that's parallel to P, which is not going to generate any torque, and a component that's perpendicular to P, which is going to generate some torque. So we'll do it in blue so we can see it. So here are the components of F2. There's one that's perpendicular, one that's parallel and one that's perpendicular. The original vector always has to be the hypotenuse. Now, of these two components, so we know the hypotenuse is 200, only the one that's at 90 degrees to the distance is going to generate some rotation. So we need to figure out what F2 perpendicular, I guess we could label it, what that value is. So if I want to calculate torque 2, I need to go F2, the perpendicular component, times 2 meters. Now if you look on this little triangle, the hypotenuse is 200. We're trying to find the opposite side if I'm using this angle 30, so I want to use sine. So F2 perpendicular will be 200 sine 30 times 2 meters. And that's going to give us 200 sine 30 is 100 times 2 is 200 Newton meters. And again, if you look at that perpendicular component, it's acting kind of down like that. It's going to cause it to rotate clockwise as well. Now, the only one left is F1. F1 I've left to the end because it's got a bit of a complication with the angle. But again, it's acting at an angle slightly above this little vector they've labeled U. So if you look at it, it's going to cause it to spin the other direction because it has a component that's perpendicular opposite to F2 perpendicular. So if I look at F1, there's a parallel component which isn't going to generate any torque and a perpendicular component. So to find torque 1, I want to go F1, the perpendicular component, times 2 meters. Now, we know the value of the hypotenuse is 200. That's stated in the question. What about the angle? Well, if you look at, here's y and here's x, and we've got a couple of angles. This is 35 and this is 30. We know that all of this is 90 degrees. So if I know 35 and 30, that adds up to 65. This will be the remainder to add up to 90. This little sliver right here has to complete the 90 degrees. So 90 minus 65 will give me that angle.
So that little angle, I'll just label it theta. Theta will equal 90 minus 65, my apologies. 90 minus 65 degrees, which is 25 degrees. So this little side here will be 200, and since it's opposite to the angle, 200 sine 25. There's my perpendicular component times 2 meters, and that gives me 169 Newton meters, and we've already established that this one is counterclockwise, CCW.